The absolute global maximum of a function is the y value that is greater than or equal to all other y values in the function. The absolute or global minimum of a function is the y value that is less than or equal to all other y values in the function. A relative or local maximum of a function is a y value that is greater than or equal to all the nearby y values, and a relative or local minimum is less than or equal to the nearby y values. Extrema, also called extreme values, are either maximum values, the plural for that is maxima, or minimum values, the plural for that is minima. Critical numbers are x values at which f of x exists, but f prime of x is either 0 or undefined. The extreme value theorem will pop up once in a while on the AP test, and it states if f is continuous on the closed interval a to b, then f has an absolute maximum and an absolute minimum on that interval. Same conditions as intermediate value theorem. The candidate test is our procedure for finding absolute global extrema. Find all critical numbers of the function, and then find y values at each critical number and at each endpoint of the interval, and then choose the least and greatest y values as absolute extrema. Note that absolute extrema can occur either at critical numbers or endpoints, but relative extrema can only occur at critical numbers. Use the graph of y equals f of x at right to find the following. What is the absolute maximum of f? The absolute maximum is the greatest y value. And the greatest y value anywhere on f is 4. At what x value does f have an absolute maximum? -4. What is the absolute maximum point on f? What is the absolute minimum of f? Remember that absolute extrema can occur either at critical numbers or endpoints. Let's take a look at those critical numbers. We have a critical number when f of x is defined, but f prime of x is equal to 0 or undefined. If our slope of the tangent is 0, then we have a critical number. So we have some critical numbers. One is at -3. -1 is also a critical number because my slope is 0, meaning the derivative is 0. What about at 1? 1, we have a critical number because the slope is undefined, right? This is a sharp turn. Where is my tangent line? At x equals 2, f of x is not differentiable, meaning the derivative is undefined. So we have a critical number as long as f of x exists at this point. Yes, there is a defined value for f of x at x equals 2, which makes 2 also a critical number. Now you may wonder why we would even talk about all these critical numbers when we can see that the absolute minimum is where the graph is the lowest, and that looks like it is at 4 or approaching x equals 4. But that's the thing, the absolute minimum does not occur at x equals 4 because f is not defined there. I know that it's not going to be a y value of one of these critical numbers because none of those are the absolute lowest point that I can see on this graph. So if the absolute minimum cannot occur at any of these critical numbers, but it also cannot occur at this endpoint because this endpoint is not defined, then f has no absolute minimum. At what x values does f have a relative minimum? Remember, relative extrema only occur at critical numbers. So we have -3, -1, 1, and 2 as options. A relative minimum would be a y value that is less than or equal to nearby y values. So at -2, y equals 1. Is that less than the y values around it? Yes, it is. So we have a relative minimum at x equals -3. What about -1? Now this one looks like it might be a relative max. So x equals -1 is a relative max because it is greater than the y values around it. X equals 1 gives us y equals 1, which is less than or equal to the y values around it. And x equals 2 is 1, which is technically less than the y values surrounding it. So we have a relative minimum at x equals -3, 1, and 2, and at x equals -1, we have a relative maximum. Find the global extrema of f of x on the interval -1 to 3. First of all, is there any place where f of x is undefined? Because if so, that will not be a critical number. F of x is a polynomial, so it is continuous, defined for all x's. Let's derive using the power rule. To find critical numbers, we're going to make f prime of x equal to 0 or check when it's undefined. Again, we have a polynomial, so it's continuous and not undefined. Our two critical numbers are 0 and 4. Step 2 is to determine the y values at the endpoints and at the critical numbers. Notice that the critical number 4 is outside of our interval, so we don't actually need to test it out. So here are my options: -7/3, 0, and -9. My global maximum would be the largest of those numbers, so y equals 0. And my global minimum would be the smallest, y equals -9. Find the absolute maximum and minimum values for f of x equals absolute value x minus 2 on the interval 0 to 5. We do not have a particular method for deriving absolute value functions, so we're going to take a look at the graph. Absolute value x minus 2. The absolute value x graph is this, the parent graph. X minus 2 means we've shifted to the right 2. An absolute value function only has one critical number, and that is the x value of its vertex. It's pretty clear from the graph where my absolute minimum is, but let's go ahead and check our endpoints and our critical number. We already could see our absolute min was at y equals 0. Our absolute maximum is y equals 3. Find the extrema of f of x equals 3x to the 2/3 minus 2x on -1 to 3. First, is this function undefined for any x values? No, it is not. It is continuous. Let's derive. 2/3 times 3 is 2. 2/3 minus 3/3 is -1/3. Now it's time to find critical numbers. Critical numbers occur where f of x exists, but f prime of x is equal to 0 or undefined. It may be easier to see where f prime of x is undefined if we write our negative exponent in fractional form. Here you can see that if x was 0, we would have 2 divided by 0, which is undefined. So f prime of x is undefined at x equals 0. One of our critical numbers is x equals 0. To find any other critical numbers, we'll make f prime of x equal to 0. Our other critical number is x equals 1. Both of those critical numbers are on our interval, so now we'll test our endpoints and each critical number. If we used a calculator to evaluate the decimal version, we would get 0.240. So my options for the extrema of f of x would be 5, 0, 1, or 0.240, making our global or absolute max y equals 5 and our global or absolute min y equals 0.